Well, good afternoon. This is another YouTube video for my class. What we're going to be talking about this afternoon is just simply reviewing adding and subtracting fractions. This is something that you were taught in pre-algebra, and I just think we just need to review it. A lot of you have forgotten it, so hopefully you'll review this YouTube video as often as you can. First of all, what I want to talk about is the idea of number one. First of all, number one is, and along with any other number, we can write it in a lot of different ways. But for number one, we can write it as 2 over 2. We can write it as 3 over 3, and so forth, as many numbers as we want. And that's really important to realize that numbers can be written as ratios or fractions in many different forms. The other thing that we need to remember about the number one is the identity factor and the identity property of 1. And 1 times anything is that anything. So 1 times 4 is 4. 1 times 6 equals 6. And 1 times, say, 5 equals 5. 1 times a million is a million. And so with these two unique properties of numbers and the identity property of 1, it allows us to do fractions. Another thing that we have to realize about fractions is the fact that fractions come in a lot of different flavors. This bottom number tells us how many pieces or slices a whole unit is divided into. So this represents a unit is divided into 3 pieces, and I only have 2 of them. This represents a unit that is divided in 5 pieces, and I have a negative 4 of them. So in other words, we have to realize that these fractions are divided into different units, and to be able to add and subtract the numerators on top, we have to get the units on the bottom to be identical. So this is where the idea of the number 1 comes in. We know that 1 times anything is that anything. So if I have 4/5 and I want to rewrite this, say I want it to rewrite it to where it represents some other number, or not represent some other number, but it looks different from this number, I can multiply it by 1 in the form of 2 over 2. So 2 times 4 is 8, and 2 times 5 is 10. So in other words, the fraction 4/5 is the same as 8/10 on the number line. And that's significant to realize that. Let's take this a little bit further. Let's say we take 4/5 and I multiply it by 4 over 4. That gives me 16 over 20. So now the 3 fractions of 16/20, of 8/10, and of 4/5, they all occupy the same point on the number line. Therefore, their values are equal, even though the way the numbers look, they're made up of different symbols. So that's significant to remember about the number fractions and using the number 1 to rewrite them. So let's go ahead and erase this, and hopefully you'll remember that idea, and we'll go ahead and simplify these two ratio expressions. So let's take a negative 4/5, and if you look at this 5 is missing the 3. So what I want to do is multiply 4/5 using the number 1 as 3 over 3. And the reason why I want to use a 3 is because the 5 is missing this 3. So this becomes a negative 12/15. Okay. Now let's go ahead and let's do the other part of this. Now the other part is the fact that I have 2/3. Now 2/3, the 3 on the bottom is missing the 5. So I want to multiply the top by 5 and the bottom by 5. So now when I take these two fractions, I get a negative 12 fifteenths plus 10 fifteenths. Now the integer math, reminding you of that, I take the larger of the two values, subtract the smaller from the larger, that gives me 2. The denominator stays the same. And what will my sign be? Well, the sign is given by taking the sign of the larger of the two numbers. So that fraction ends up, that simplifies to a negative 2/15. Now the same principle holds true when I'm doing more than just two numbers. So we're going to go ahead and do this one. So I've got 4/5. And again, it's missing the 3 and the 4. So 3 times 4 is 12. So I'm going to multiply this one by 12 over 12. Now the 2/3 is missing, it looks like the 3 is missing the 5 and the 4. So I will multiply this one by 20 over 20. And then the last one, 4, is missing the 5 and the 3. 5 and the times 3 is 15. Oops, I've already got the negative there. Let me take that off. So that would be a negative 7/4. And the 4 is missing the 5 and the 3. So that would be multiplying it by 15 over 15. So now let's go ahead and let's simplify this and see what we come up with. So that gives me a negative 48. 2 times 20 will give me a 40. And 7 times 15 will give me 105. And if you look, 3 times 20, 5 times 12, and 4 times 15, everything has a denominator of 60. So each one of these units are cut into 60ths. Now to finish this problem, let's just simplify the numerators. A negative 48 plus 40. That gives me a negative 8. And then a negative 8 minus 105. Now reminding you of the integer math, if we're adding and subtracting integers and they have the same sign, we add them and then keep the sign. So that should be a negative 113. (113) over 60, correct? And the sign is negative. So as far as these numbers, when we have an improper fraction like this, don't simplify it for what we're doing right now. We know that would be 1 and what, 50, negative 1 and 53/60ths, but don't simplify it. Let's just keep it the way that it is, and we'll work on that later. What the main thing that I want you to deal with is just being able to do the integer math, be able to get the common denominator, and we'll worry about simplifying them later. So this is all that I have for today. Make sure you do your homework. I promise you that if you do your homework in class, and make sure that if you don't get it done in class, make sure you get it done at home. It should be a good experience for you. So happy homework and have a good afternoon. Thank you.